So now we have construction 5, and in construction 5 we want to construct a line that's parallel to a given line through a given point. So the line that we've been given is K, and the point that we've been given is P. And if we want to draw a line parallel to K, that means that that line cannot touch K at any point. They will never intersect. But it will also have to be through P. So we have a new axiom with this, which is axiom 5, which says that given any line and a point that is not on the line, there's exactly one line through that point that is parallel to the line. And we can go through that in more detail later. But to run through what we need for our construction, we will need our ruler, our set square, and also a pencil. So with the three of them, we can complete this construction. So it starts off with us lining up our set square so that one side of the set square runs along the line that we've been given. Then we get our ruler and we place our ruler along the side of the set square that is at a right angle to the side that's along the line. So in this way, I can now slide this up and down, but I'll leave that where it is, and I can slide the set square up and down. So now if I drew a line here, it would be parallel to K. So I have to slide the set square up far enough that it touches P, and then I will draw a line straight across. Now if I want, I can make this line a bit longer, and I'll be just very, very careful to make sure that I try and keep it as accurate as possible. Keep it going there. And we'll say I'll label this line that I've drawn L. So now if I was to check, I could check that both of these are parallel to each other as if I drew a line perpendicular to both of them, they would have angles of 90 degrees with that transversal. Or I could also draw a transversal and check that the vertically, or not the vertically opposite, but that the corresponding angles were equal, and so on. Now to show another demonstration, so that let's say I won't always be given a line that's perfectly horizontal. Maybe I'll be given a line that looks like this at a bit of an angle. We can label this line T, and maybe I'll be given a point, and we'll call that point A. So now I want to draw a line that's parallel to T through A. So as before, with my set square, I'll make sure that my set square lines up so that if I could continue this line with the set square, then I'll place the ruler along the other side that's perpendicular to it, and I slide my set square up. So now I can draw a line through A that will be parallel to T. So maybe I'll label this one Q. Now, with this construction, we will need it for one of our theorems, which is Theorem 4. In Theorem 4, we want to prove that the three angles in a triangle sum to 180 degrees. To do this, we have to draw a line that's parallel to one of the sides and goes through the vertex opposite that side. So in this case, I'm going to draw a line that's parallel to the side AC. So I place my set square down here along AC, and then I can use my ruler to move that up so that it's parallel and draw a line. So now I have a line through B that's parallel to AC, and I'll need this to prove my fourth theorem that proves that the three angles in a triangle add up to 180 degrees. So that's that this angle, and this angle will all add up to 180 degrees when measured.